Good morning, students. Today we will start new chapter, chapter 8, Binomial Theorem. Today we will discuss introduction of the Binomial Theorem. In previous classes, we have studied about these identities, a plus b whole square, a square plus 2ab plus b square. Second identity, a plus b whole cube, that is equal to a cube plus 3a square b plus 3ab square plus b cube. This identity can be written as, I think you have remember it, this can be written as like this. This can be written as like this. Yes, this can be like this. Here is the a cube plus b cube plus 3ab into a plus b. I think now you can recall it. This identity we have learned in class 8. Now a plus b whole to the power 4. This can be, and this can be also solved in the classes 9th or 8th. A plus b whole cube into a plus b, and you can write it a to the power 4 plus 4 into a cube b plus 6 into a square b square plus 4 a b cube plus b to the power 4. I think you recalled all these identities. Now further in this chapter, how we use these identities, how these identities are helpful, and what are the important points which we observe from these identities. Let's see. Here are few important points which you can observe from above identities. Here I have just told about 3 identities. In right hand side, I have written a plus b whole power 0 is equal to 1. Any number having power 0 is 1, you know it. And this you have studied in class 8. And a plus b whole power 1, it means what? This is written only once, a plus b. Okay. Now if you observe with the index 0, 1 and index 2, 3 and 4. Now what you will observe from these, first point is, which you will observe, that is, first point is two numbers of a total number of terms. How many is the index given? Add 1 in it, you will get the total number of terms. As you can see above, yes, here in the power 2, you are getting 3 terms. When power is 3, or you can say index is 3, then you are getting 4 terms. If index is 4, then you are getting number of terms 4 plus 1, 5. 1, 2, 3, 4 and 5. 5 times you will get. It means what? Total number of terms, index plus 1 or power plus 1. Power or index, you can use these two words for the power. The second point which you will get, that is power of the first quantity go on decreasing by 1, whereas the power of the second quantity go increases by 1 in the successive terms. First quantity is A, second is B. Now you can see here in the, this first quantity is A, power in first term is A square, it is power is 2. In the second case, power is 1. In last, there is no power, it means what? Here is a to the power 0. In the second identity, you can observe here, first a having power, this is 3, then 2, then 1, and here it is a to the power 0. So you can see what? The power of a is decreasing. If you observe b, the power of b is increasing. Here is what? B to the power 0, then this is 1, this is 2, and this is 3. It means the power of a, first quantity, that is decreased, and first term b, sorry, second term b, it is increasing order. I think you can understand second point. Now further for the third point. For the third point, Now come to the third point. In each term of the expansion, the sum of the indices of A and B is the same and equal to the index of A plus B. Index means par. Index means par. Here I have written par. Now go back. Yes, that is 2 plus 1, that is 3. 3 plus 0 of b to the power 0, I have written already Pel. 3 plus 0, that is 3. This is 2 plus 1, 3. 1 plus 2, 3. This is 3. It means in each term, you are getting sum of the powers of A and B is equal to power of expansion. A plus B whole power 3. It means all are having power 3. If it is 4, then this is 4. 3 plus 1, that is 4. 2 plus 2, it is 4. 3 plus 1, that is 4. And 4 plus 0, it is also 4. It means third point is now clear. Come to the next point. Here in the binomial theorem, we will discuss only about the positive integral indices. It means only we will discuss about the positive power of the given expression. Now come to the few observations. If index was 1, in the previous sheet, index is 1, then the coefficient is 1. What it was written? And if the index is 1, then here you can write A plus B whole power 0. It means coefficient is 1. If A plus B whole power 1, it means what? This is A plus B. The here coefficient is 1. Here is coefficient 1. If it is here, right? Yes, this is A plus B whole square. It means A square plus 2AB plus B square. What is the coefficient? Here is 1. Yes, this is 1. Second is 2. Here is 2. This is 1. This is 1. Now I have to write down now identity. You know, in the previous sheet it is written first coefficient 1, second term coefficient is 3, third term coefficient is 3, fourth term coefficient is 1. In the power A plus B whole power 4, it is 1, 4, 6, 4 and 1. It is known as the Pascal's triangle after the name of the Blaise Pascal. This is a mathematician's name. On the base of this name, the pattern is known as the Pascal triangle pattern. Suppose if we proceed it further, I think you can write along with me. First and last coefficient will be same. This is 1, 1. And let's erase it. Yes, I'll write it here. If proceed it, if it is 1, then 4 plus 1, that is 5. 4 plus 6, that is equal to 10. 4 plus 6, this is 10. 4 plus 1, it will be 5. And last one will be 1. If the index is 5, it means if the expression having power 5, then the coefficients of the first term, second term, third term, fourth term, fifth term and sixth term will be these 1, 5, 10, 10, 5 and 1. Now you can observe in the next example. Yes, see here 2x plus 5y whole power 5. If I expand it, first term in power, decreasing power, 2x to the power 5, then 4, then 3, then 2, then 1 and last is 0, not written. Okay. Now if I'm talking about the b, here b is 5y. If this then power of this will be in increasing order. Here it is 0, it is 1 here in the second term, then 2, 3, 4 and here it will be 5. Write down it is 5. Okay. So what you can get from above? Coefficient, first coefficient will be 1. It is 1 here. What is it? This is the second coefficient. The third coefficient 10. This is the fourth coefficient, fifth coefficient and last is 1. I think you can get the coefficients of the given expansion by the above pattern, by using the above pattern. Here, when I'm talking about coefficients, we can write the coefficients of the by using the combination. Yes, we can write coefficients by using the combinations. As I have written in a Pascal triangle, all these coefficients which I have written above can be written as in the form of combination. We have studied the chapter permutations and combinations. Now by using the combination, we can write the coefficients. 1 can be written as 0 C0. As I think you know about, if you have studied the chapter permutation and combination, NC0. How to calculate? By using the formula NCR is equal to factorial n upon factorial r into factorial n minus r. If it is 0 C0, it means 0 factorial upon 0 factorial into 0 factorial. As we already studied, 0 factorial value is 1. So 1 upon 1 comes out 1. It means this is 1. Similarly, you can solve. It is 1, this is 1, this is 1, this is 2, this is 1, and this is 1. This is 2 plus 1 comes out equal to 3, 2 plus 1 equal to 3, and this is 1. I think you can do by using the combination also. In journal, when I write binomial expansion, I will use at the place of coefficient combination. Now, by observing above explanation, we can write a plus b whole power 7 expansion. We can write like this. First coefficient 7c0 a to the power 7. As first one will go. Let's discuss. Take the mouse. Yes. A plus b whole power 7 is equal to 7c0 a to the power 7. Power of a will be in a decreasing order, and the power of b will be in a increasing order from 0 to up to what? 7. How much is the maximum? That is 7 given to you. 7c1 a to the power 6b plus 7c2 a to the power 5a square, and so on. How many times you will write down? 7 plus 1, total 8 terms. 1, 2, 3, 4, 5, 6, 7, and 8. Total number of terms will be 7 plus 1. For any positive integral index, we can write. Now, this is a formula of the binomial expansion. If it is written in journal, then how to write? A plus b whole power n is equal to nc0 a to the power n plus nc1 a to the power n minus 1 into b plus nc2 a to the power n minus 2 b square, and last term will be what? N plus 1th term. Because number of terms are n, so last term will be n plus 1th term. As we start from 0 to n, if it is 1 to, then it will be up to n plus 1. This you have to remember. So ncn b to the power n will be the last term of this expansion. Total number of terms will be n plus 1. Sometimes students think about it is 0. How you will get write down? How you will get the n here? Because you are starting from 0. If 0 to 9, it means you are getting 10 terms. If 0 to 12, you are getting 13 terms. 0 to 12, you are getting 13 terms. It means 0 to n, you are getting n plus 1 terms. It means you have to understand the concept. Now, how to brief the concept regarding binomial expansion? Here are few observations which you can observe. First observation is how to write down this expansion in a summation form, in a compact form. A plus b whole power n can be written as summation sign. This is a summation sign. I think commerce students can understand it very easily. Science students also, but this summation is there. K is equal to 0 to n. From 0 to n you are going. N, C, K, a to the power n minus 1, b to the power k. The meaning of this is that if you put k is equal to 0 here, you will get first term. If you put k is equal to 1, second term. If you put k is equal to n, then you will get the n plus 1th term. As I put here, just try to put, I'll show you. Okay, you can put here, yes. If you put k is equal to 0. Put here, you'll get NC0 a to the power n minus 0 b to the power 0. What's the meaning of this? NC0 a to the power n and b to the power 0 means any number having power 0 is equal to 1. So what are you getting? You're getting the same first term. As you put k is equal to 1, you will get the second term, third term, and when you put k is equal to n, you are getting last term. This is the way to write down. Now next, yes, NCR is a binomial theorem. NCR is a binomial theorem, yes, are called, and in the binomial theorem it is called binomial coefficients. It means when you write here NC1, NC2, NC3, you will call them, these are the binomial coefficients. Third, number of terms in the expansion is equal to 1 more than the index. As I have told you in the previous sheet, if the power is 7, then you're getting 7 plus 1, 8 terms. And if the power is 2, then a plus b whole square identity having 3 elements, 3 terms. So what? 1 more than the index. Fourth, in the expansion a plus b whole power n, as we have studied, a goes on decreasing order, b goes in a increasing order. Okay. As a sum of each term, I have told you, if you add the power of a and b, you are always getting the index. N minus 1 plus 1, getting n. N minus 2 plus 2, you are getting n. N minus 1 plus 1, you are getting again n. And b to the power n, and a to the power 0 means n plus 0, you are getting n. It means what? Either you are getting power of a and b both same, or their sum is equal to index. Now apply the binomial theorem on the given question, that is expand x square plus 3 upon x whole power 4, where x is not equal to 0. I think you know about it. If x is equal to 0, it means this term becomes not defined. That's why it is written here, x is not equal to 0. Now you know the identity a plus b whole power n. Here the value of a is x square, b is 3 upon x, and n is equal to 4. Now in the expansion, you have to put n is equal to 4. 4c0 x square to the power 4, a to the power 4. A is given x square. B to the power 0 means you have not to write down. Simple, it is 1. That's why 4c1 x square whole power 3 and second term power 1. First term power 2, second term power 2. Both are same. First term having power 1, this becomes 3, and write down the last term. Simplify this, you will get the expansion of the binomial on the expansion x square plus 3 upon x whole power 4. That is the answer. If suppose here is a minus sign. Suppose if you take here, the sign is minus. Suppose statement is x square minus 3 upon x whole power 4. Then what is b? Here a is x square and b is equal to minus of 3 upon x. Remember it. You have to pick the sign along with the value. So what? If you write here, then the minus sign will be there if the statement is with the minus sign. Then simplify it, you will get the answer. Different answer will be there. Solve this question along with this question by taking the sign. What is the statement? I have write down again. Solve it again. Suppose statement is x square minus 3 upon x whole power 4. Expand it by using the binomial theorem. How to take the minus sign, you will get the idea about it. Now next one is, here's the next question. Which is larger, 1.01 whole power 10 lakh or 10,000? Now you have to what? In 8th class, I think you have done this question, 1.01 whole power. This question like this. 1.01 whole power 3. Then you wrote in that class like this, whole power 3, and apply the identity. Which one identity? A plus b whole cube, and you will get the answer. Now here the power is 10 lakh. It's very difficult to solve it, but by using the binomial expansion you can do the question. Now here is what? 1 plus 0.01 whole power 10 lakh. Then what? NC0. N is this statement. NC0 10 lakh, C0 10 lakh, C1. A to the A is 1. It doesn't matter whether you have to write 1 to the power 2, 3, 4, 5. That's why it is not written here. So the B I have taken in the first term, it is power having 0. That's why I have not taken, it is 1. So here is power 1, and next term having power 2. 0.01 having power 2. And so up to the terms. How many terms you have to get here? 10,000. Number of terms कितने आएंगे यहाँ पर? 10,000 plus 1 up to these terms. Okay. If you simplify it, you are getting what? In the first case, NC0 is 1. Here, NC0 is n. Put the value of n here and simplify it. 1 upon 100. Cancel it. You are getting 10,000. And other terms are also with it. Up to the 10,000 10 lakh plus 1 terms. Now you are getting sum of 2 terms, first 2 terms, these 2 terms, sum will be equal to 10,001. Yes, you are getting 10,001 plus other terms. It means what? You will get greater number of 10,001. So what? You can compare 10,001 plus more. That will be what? That will be greater than 10,000. It means what? The expansion 1.01 is greater than 10,000. Okay, because the sum of all these terms will be equal to 10,001 plus more. Okay. Now next one is example number 4. Using the binomial theorem, example number 4. Using the binomial theorem, prove that 6 to the power n minus 5n always leaves remainder 1 when divided by 25. Now here I have given you an idea how you will divide. I think in previous classes you know how to divide. 6 to the power n minus 5n written inside and 25 is dividing. You are getting quotient q. What you are getting? Remainder 1. This is given to you. What it means that you can write this statement: divisor into quotient plus remainder, that will be equal to dividend. Here I have written. Yes, 6 to the power n minus 5n will be equal to, dividend will be equal to divisor into quotient plus 1. It means my target is to what? Write down the given statement in the form of 25q plus 1 by using the binomial theorem. Now how to do this? Let's do. In this question, you have to mold the binomial expansion. Yes, mold the binomial expansion. Normally we have written a plus b whole power n. In such type of cases, you have to take what? A plus b whole power n expansion. By using the a plus b whole power n expansion, a plus b whole power n expansion, where NC0 a to the power n b to the power 0 plus NC1 a to the power n minus 1 b power 1 and up to last NCn a to the power 0 b to the power n. Normally we use this expansion, but here in the case this you want numerical value. You have taken 1 as your own. Take a as 1 and b as a. You can write b here also, no problem will be there. You can do the question like taking b, a 1 plus a whole power n. Now make the expansion like the binomial. Make the expansion as binomial. You write like this: NC0, NC1 whole power a having power 1, a square increasing order, second quantity having increasing order, and the first quantity having the decreasing order. 1 having any power, you will get 1. That's why I have not written here 1. So you are getting this expansion. Now if you want 6 to the power n, what you have to put to here at the place of a? You have to put a is equal to 5. Now put a is equal to 5 in the expansion. You are getting left side 6 to the power n, nc0 plus nc1 into 5, nc2 into 5 square, and up to ncn into 5 to the power n. Now second aspect is what? You want 6 to the power n minus 5n. Now first of all, simplify the coefficients which are written in the combination. Now write in a numeric form. NC1. Here you have to write down. I have written in the, you can write it here like this. NC1 will be equal to n. NC0 is equal to 1. NC2 will be as it is, and this is as it is, this is as it is. Because this is a requirement of the question, you have to take it to the left hand side. Now what it becomes? 6 to the power n minus 5n, and other terms are 1 plus n 5 square. You are taking common from these all terms. If you are taking 5 square common, it means you are decreasing power by 2. Enough? 5. NC2 plus 5. This is 5 to the power 3. When you are taking 5 square common, it means what? Minus 2. You are getting what? Only power 1. If it is power 4, you are taking common 2 power, it means 5 square is left. Here 5 to the power n minus 2. Now what is this? Assume that this is the quotient. Assume that this is a quotient. This is a quotient. I have 2. This is quotient. Then what? Write down this is Q. This is Q. And this is what? What is the requirement of the question? Question requirement is this one, this one. And we get the same one here. So meaning of this I have told you earlier. What is the meaning of this? When you divide x to the 6 to the power n minus 5n by 25, you are getting remainder 1. It means what? This is also the way to write the question by using the binomial expansion. Now do the questions regarding the binomial expansion. Exercise 8.1 examples. Try to do questions of exercise. If you can do, it will be nice for you. Thank you and have a knowledgeable day.